Hello, today we're going to modify a HP server power supply. In this particular case, we're going to modify this HP HSTNS-PL11 12-volt DC server supply to power an Avalon6 Bitcoin miner. These are really inexpensive to find on eBay. I picked this one up for $25 with free shipping. Just look for one of these part numbers that are on the supply here, 490-594-001. That's an easy model number to search for, or 438-203-001 or 498-152-001. These make great Bitcoin mining supplies. They are really quiet and they're relatively easy to modify. First thing we want to do upon unpacking the supply is to test it and make sure it powers up. And these, by the way, these take anywhere from 100 to 240 volts, but the amount of power you can get out of them is going to vary depending on your voltage supply. If you're supplying 120 volts, you can get 900 watts. If you run this on 240 volts, so you can get a full 1200 watts. It's 100 amps at 12 volts. So let's power this up and see if it works. Now, if you've never used one of these HP server supplies before and had to manually power one of these up, it's not that hard to do. Essentially, what you have to do is take this pin right here, pin number 33. It's the first one on the left on the top side, and apply a 470 ohm resistor from that pin to the fourth pin in number 36, and the supply will power right up. To demonstrate this, I don't have enough hands to hold the multimeter probes and the resistor at the same time, so I'm going to go ahead and clamp my negative probe under this alligator clip and put it right here. By the way, this is the negative supply rail and this is the positive supply rail. And then we're going to take very, very carefully, I'm going to put my multimeter probe on here and I'm going to apply the resistor across here. Whoop, don't want to slip. Let me bend that lead just a little bit more in. Apply the resistor across those pins, and there you go. The supply powers right up, 12.269270 volts. Now these supplies will put out about 12.3 volts, give or take a little, unloaded. When a load is applied, they are almost spot on 12 volts even, 12.003 thereabouts. Now for most HP supplies, that would be the end of the story. You would just solder your resistor across those two pins, and whenever you apply power, the supply would start right up, no problem whatsoever. However, these HSTNS-PL11s, they're a little bit more difficult to work with because they have they require a time delay between the time you apply power and the time it'll accept the signal to start up. It's not a real long time delay, but it is there, and if you just solder the resistor here, as soon as you disconnect power and reapply it, say a power outage, when power comes back, the supply doesn't start up until you remove and replace the resistor. And that's not what we're looking for here. So what we're going to do, let me move the multimeter out of the way, is we're going to add a couple of extra parts. We're going to add an NPN transistor and a 100 microfarad capacitor along with our 470 ohm resistor. Now there's nothing special about this NPN transistor. It's a TIP31. It's way overkill for the job, but I've had a drawer full of them, so I'm just going to go ahead and use it in this particular case. So let me move this camera and set it up for us to solder the parts on. I'm just going to solder straight on here. You could make a nice fancy breakout board, but I'm going to be cheap and just solder them right onto the edge of the supply. So let me stop the camera, get everything set back up for the shot, and we'll do that. Alright, we've powered down our power supply. Definitely don't want to work on it with the power on. And we've got our NPN transistor here. The pin order on this one is base, collector, emitter. So first of all, I want to take the base and bend it upward toward me to get it out of the way. And then we're going to flip it over. And the collector is going to go to pin 33 and the emitter to 36. And to do that, I need to bend these pins a little bit. Yeah, a breakout board would probably be better than these pins just flapping in the breeze, but this will do the job nicely. And let's see how that fits. Not bad. I'll need to bend this one a little bit more. And that'll be perfect right there. That's a perfect fit. So let's get some solder out here, and I'm going to go ahead and put a little bit on this pad over here. And on this pad here. And let's put these on. Just get them started there, and then we'll put some more on. And that'll do the trick. And then let's flip it over. And we'll go ahead and trim the lead on our 470 ohm resistor here. And we'll wrap it around this base here. Yeah, once again, a breakout board would be much nicer. But this is the inexpensive way. Just tack that on there a little bit. And then we're going to solder to the base of the transistor here. And then we'll just put a little bit more back here. Get that all good and solid. Okay, let that cool down for a little bit. Trim this lead off here. And we'll flip over again and get our 100 microfarad capacitor. Now I want to make sure the polarity's right on this one. Negative lead will go to the ground plane here. I'm going to put a dab of solder on there, just a dab. Turn this lead back just a little bit. Camera can't see what I'm doing here. Flip her over. And line it up with that lead from the resistor. And trim off our excess. And what this will give us is the appropriate time delay to have this power supply power right up. So now if I turn it around and we can test this out, I'll plug in the power, and there you go, green light on, power supply is running, just like that. Disconnect power, reapply it, there we go. Perfect. It's really that simple to power one of these up automatically. Next thing, connectors. I've made these pigtails up already. I get to solder all of these onto here. So let me go off camera and do that and come back. Alright, I'm back. And here is our finished HP server power supply with the pigtails wired onto it. And it took a lot of heat to do that. That's a big plane there. But it took a lot of heat and a generous amount of flux, but they're all on there and they're good and strong now. Not going to go anywhere. So the next step, well, first of all, if all you need is a 12-volt supply, good to go, done now. But if you need some more voltage, let's say you want 12.2 volts for an Avalon6, the next step is to remove these screws, and we're going to change the voltage of this supply. Ah, there we are. There's the inside. Now you have to be really careful inside one of these power supplies because you don't want to electrocute yourself. Even when the power is not applied, there still is a lot of charge in these capacitors in here. So you have to be really careful with these. Now let's flip it around here and look at this board. And my understanding is, I believe that this potentiometer right down there should be the 12-volt power adjust. I'm going to go online and verify that right now, but I believe that is the voltage adjust right there. Alright, now I've verified online that is in fact our voltage adjustment. So what I'm going to do first, I'm going to go ahead and get a reading of what that's set to, just so I know before we try to adjust anything. I wish to know what that's currently set to. Oh, okay. Got like 56 ohms one way and 0.4 ohms the other. That's not what I expected. Okay. I don't see a voltage change. Okay, I'm back. It seems that the instructions I found online for this power supply were incorrect as to the location of the voltage adjustment potentiometer. The instructions online suggest that this is the potentiometer. Before I actually adjusted anything, I took some measurements so I could know what resistance it was set at to begin with, and I'm glad I did, because that is not the voltage adjustment potentiometer. That one seems to be some sort of frequency for the pulse width modulation or something, because when I adjust it, the voltage stays the same, but I can hear the pitch and the transformer whine inside the power supply changing. The voltage adjustment potentiometer appears to actually be this one up here. Let me go ahead and power up our supply, and we'll be very careful with it. And we'll get our probe put in position to measure it. Come on. You can do it. There we go, 12.21. And that's not loaded. I'm going to go ahead and put a load on this power supply. Loaded, we are exactly 12.012. I've already fiddled with the potentiometer a little bit. It was 12.002 or something like that to begin with. This is the potentiometer. Counterclockwise is more voltage, and I can turn it all the way up to a value of 12.5 420 it looks like. I've had it to 427. And turning clockwise lowers the voltage. And it looks like I can go down to 11.577. And if you turn it too far, it'll shoot all the way around, so you gotta be careful with this. So that is the voltage adjustment range on this power supply. And that's a reasonable adjustment range. Unfortunately I can't get all the way up to 12.8 or whatever, but I don't really want to burn out my miner anyway. So that is it. And I'm going to go ahead and shut this off because I don't like running these power supplies with the cover off of them. And what I've done to make this easier to fine-tune after stuff is actually in use is I have drilled a hole. I had to cut back the little black material in here, and I've drilled a hole that lines up exactly with where that potentiometer is at. So I can put this back on here. Make sure that flap is up. I can put it back on there, and you'll see right there I can access this potentiometer from the outside. Obviously I'd have to be very careful to not let it touch the case or anything while I'm doing the adjustment. And when I'm done adjusting, I can put a little piece of electrical tape over there to cover it up. Now I just need to fasten it all back up and it's good to go. A power supply for an Avalon 6. If you like this video, give it a thumbs up and click on the subscribe button below. Tips and donations are welcome and appreciated at the Bitcoin address on your screen and in the description.